This is everything you need to know for Algebra 2, Part 10. So we're talking about systems of equations with three variables today. So you probably learned about systems of equations in Algebra 1 and probably even used them in geometry some, but now we're adding a third variable, okay? The process isn't too much different, but it is a little bit trickier. So we have the system of equations 3x minus 2y plus 4z equals 35, negative 4x plus y minus 5z is equal to negative 36, and 5x minus 3y plus 3z is equal to 31. So we are going to be using the elimination method today, which if you remember from Algebra 1 basically means that we need to find a variable that we can cancel out. So just looking at our first two equations, I noticed that we don't have anything that can cancel out yet, but I see a positive y right there and a negative 2y right there. So if we multiply our second equation by 2, then we would end up with a negative 2y and a positive 2y that would cancel, okay? So I'm going to multiply this whole equation by 2 and get my new equation, which is going to be 2 times negative 4x is negative 8x, 2 times y is plus 2y, and then 2 times negative 5z is minus or negative 10z. And that's equal to 2 times negative 36, which is negative 72, okay? So I'm going to rewrite my first two equations now so that I can start eliminating that y variable. So my first equation is 3x minus 2y plus 4z is equal to 35. And I'm going to write my second equation underneath it. So negative 8x plus 2y minus 10z is equal to negative 72. So because we have a negative 2y and a positive 2y, we can add both of these equations to cancel out our y variable, okay? So I'm going to put parentheses around this one just so that we don't get any signs mixed up. And we're just going to treat it like an addition problem, okay? So 3x plus negative 8x is negative 5x. Negative 2y plus positive 2y are going to cancel. 4z plus negative 10z is negative or minus 6z. And that's going to be equal to 35 plus negative 72, which is negative 37. So I'm going to write my new equation right over here. So we have negative 5x minus 6z is equal to negative 37, okay? Now, we need to go back to our original equations now and pick two more and see if we can cancel out the y variable again, okay? So ignore the parentheses and the 2. If we just look at the second and third equation, again, I see my positive y and then I see a negative 3y. So if we multiply this top equation by 3, we would end up with a positive 3y and a negative 3y, which would cancel again, okay? That way we have another equation to pair with our new one here and have something to work with, okay? So I'm going to go ahead and multiply our original second equation by 3, okay? So negative 4x times 3 is negative 12x. Y times 3 is plus 3y. Negative 5z times 3 is negative or minus 15z. And then that's equal to negative 36 times 3, which is negative 108. Now, we're leaving our third equation the same, so I'm going to copy it down. So 5x minus 3y plus 3z is equal to 31. And again, we're going to add them. So I'm going to add my parentheses. And now we're just going to go ahead and do this addition problem. So negative 12x plus 5x is negative 7x. 3y and negative 3y cancel. And then negative 15z and positive 3z are going to make negative 12z is equal to negative 108 plus 31, which is negative 77. So now we have our new equation. I'm going to put it up here with my other one that we solved. and put negative 7x minus 12z is equal to negative 77. So notice now that our two new equations we have to work with do not have a y variable, and so we can actually solve for x and z because we only have two variables now. So let's see what we can eliminate now. The 5 and 7 are going to be kind of hard to eliminate, but we do have a negative 6z and a negative 12z, so we can just multiply the top equation by 2 so that we have a 12 and a 12, okay? So we're going to multiply everything on top by 2, and I'm going to write the new equation just right down here. So 2 times negative 5x is negative 10x. 2 times negative 6z is negative 12z. 2 times negative 37 is negative 74. Then my second equation is negative 7x minus 12z equals negative 77. So notice that my negative 12z and negative 12z are exactly the same, so we don't have opposite signs this time, okay? Now, you could multiply one of these equations by negative 1 if you wanted to. I'm just going to go ahead and multiply the top equation by negative 1, which means that the sign is going to change on everything, okay? So let's just say this is a positive 10x plus 12z and positive 74. Okay, that's just going to make it a little bit easier. So now we have opposite signs right here, and we can eliminate by adding just like we did before. Okay, if we wouldn't have changed those signs, you still could have just subtracted and got the correct answer. But sometimes subtracting negatives gets a little tricky for people, so we're going to do this. So 10x plus negative 7x is 3x. 12z plus negative 12z cancel. And that's equal to 74 plus negative 77, which is negative 3. So 3x equals negative 3. We're going to divide by 3 on both sides to get x is equal to negative 1. Okay, so we've solved for the first variable. So now to solve for z, let's just go back to this equation right here. So negative 5x minus 6z is equal to negative 37, and plug in our new x value that we just solved for. So we're going to have negative 5 times negative 1 minus 6z is equal to negative 37. So negative 5 times negative 1 is positive 5 minus 6z is equal to negative 37. We want to get the variable by itself, so we subtract 5 from both sides to get negative 6z is equal to negative 37 minus 5, which is negative 42. Now we can divide by negative 6 on both sides to get z is equal to positive 7. And so now we've solved for the second variable. Okay, so z is equal to positive 7, x is equal to negative 1. Now we just need to solve for y. So the way that we can do that is we can just use any of our three original equations. I'm going to use the top one, and we're going to plug in x and z. That way we can solve for y. Okay, so 3x, x is negative 1, so 3 times negative 1 minus 2y, so we don't know what y is yet, plus 4z, z is 7, equals 35. Now we can solve for y. So 3 times negative 1 is negative 3 minus 2y plus 4 times 7 is 28 equals 35. So now we have like terms we can combine. So negative 3 and 28 make positive 25. So we have negative 2y plus 25 is equal to 35. Now we can subtract 25 from both sides to get negative 2y is equal to 10. So we can divide by negative 2 to get y is equal to 10 divided by negative 2, which is negative 5. So y is equal to negative 5. So our final answer, or our solution, is equal to our x value, which is negative 1, comma, our y value, which is negative 5, comma, our z value, which is positive 7, and that would be our answer. So A lot of work that goes into that. So just make sure you're really strong on solving systems of equations and solving equations in general. And you need to do some practice. Okay, but once you do that, I promise you can get it. So I hope this video was helpful. If you want to see more like this, go ahead and follow this account, like this video, and leave a comment. That way my videos show up in your For You page later on. We'll see you next time.